Hi, Mick McQuaid here with Chapter 22 of our textbook, R for Data Science. This is a chapter into Part 5, communicating with ggplot, ggplot2, I should say. And in this chapter, we're told that communication differs from exploration and that we previously explored with ggplot2 to enhance our own understanding. Now we have to communicate our understanding to others, and others may not know or care a great deal about the data, so you have to make it easy for them. And the first way to do that is with labels. And the first label to talk about is the title. The title is the main entry point into a data visualization. So we've been doing things like this. So here's a visualization of miles per gallon. We're looking at engine displacement and highway mileage on the axes and dividing the display up by class. That is like compact, subcompact, SUV, that kind of class, and showing those in color. And we're also putting a smoothing line on it. You'll see this on the next slide. And what we're adding here, so we've been doing this, what we're adding here now is the labels. And the label that we're adding is title, and we're using the paste function to do that. The paste function takes strings as input and separates them by default with a space. So this will lead to the string fuel efficiency generally decreases with, and then a space, and then the next string, which is engine size. So here's the result that we get. And the title is like the invariant in Bertin's theory, if you think back to that. This is what's going on in the graphic. Wickham and Grolemund suggest that the title should be a little bit different from the invariant in the sense that Bertin might say that the title should be fuel efficiency and engine size, and Wickham and Grolemund say that you should say what the finding is. So fuel efficiency generally decreases with engine size. Remember that it's generally decreasing, that we have this one thing that prevents it from strictly decreasing, which is that the two-seaters, this class of cars, two-seaters, are extremely lightweight and have extremely large engines. So they get worse mileage because they have big engines, but they get better mileage because they're lightweight. So they as a group, are kind of outliers. And notice this smooth line through the graphic. We'll explore that again in a minute. Okay, and we can also, in addition to adding the title, there are other labels that we can add. We can add subtitles and captions. So here we have exactly the same thing. By the way, this is just saying standard. There's no standard error bars around the smooth line. So we have the title, the subtitle, and the caption, and we're using the paste function here. This is just for convenience, so that we're not running off the screen or running off the page here. And the result of this is more informative. The result of this is that we have a graphic that stands by itself better. Now we can use the labels to replace the cryptic access and legend labels. So if we look back here, we see that the axes have HWY and DISPL, and this is class. Actually, class is pretty good for that, but these two could be significantly improved. And by saying X is engine displacement in liters, highway fuel economy in miles per gallon, and the colors, the legend is going to be car type instead of class, we get a more readable result. And I just haven't put the title and subtitle and caption on here out of laziness. Okay, the next thing we can do is annotations. Annotations are labels within the graph. So for example, we can filter the best in class and annotate those points. So the best in class is the vehicle that gets the best gas mileage in a particular class. So what we're doing here is generating a list of best in class vehicles. And we're using the pipe symbol. So this entire expression that starts here and ends here goes to the assignment operator over here. So we have miles per gallon gets grouped by class, and then we filter the row number by descending highway and only look at where it equals number 1. So that's if we're descending in gas mileage, only the top scoring one gets included. So we should have as many. How many categories do we have? We have 7 classes. So this should be a list of 7 after this, and you can check that by just running this in R. Okay, and then we depict it using the same scatter plot that we've been using, but we're adding a geom to it. We're adding the text geom, and the data for the text geom is going to be best in class. So we get this version that has the names of the cars with the best mileage in their classes. So Corvette, for example, is centered directly on the point that represents Corvette. Toyota Tacoma is directly on the dot that represents Toyota Tacoma. And you can see that some of them, for example, New Beetle and Jetta, are completely superimposed on each other. They have exactly the same mileage and exactly the same displacement, same engine, presumably. And so it's not as legible as it could be. We could improve this, and we're going to improve it in 2 steps. So the first thing that we're going to do is switch from using the geom text to using geom label. So this is going to put the labels into little rectangles that we can manipulate, and we're going to manipulate it in 2 ways. So first we're going to nudge it up 2 units, whatever these units are, and then we're going to make the labels a little bit opaque by saying alpha equals 1/2. And this gives us a slightly better depiction than, the labels in general are more legible. Jetta is even more completely hidden because it's behind New Beetle, but the other ones look a little bit better. But we can do better than this still. There's a function called geom label repel in the library, ggRepel. This is actually a misprint. This isn't a function. This is a library. And what this is going to do is make the labels repel each other, and it's also putting a circle around each data point. And the labels that are repelled far enough away from the data point that they're not touching have a line now going to the data point. So this is better still, and we've left this as the default opacity, which is total opacity. Now, another way that we might want to do labeling is by, not labeling, annotations, is to get rid of the legend. So we're going to get rid of the legend, the class. So we're going to take this. This is just going to find the positions of the class averages. So, for example, the class average for this might be here, halfway on the y-axis and halfway on the x-axis, except it's a weighted average, so it isn't going to be exactly in the center of these points. So we're taking actually it's not the mean, it's the median of these. So the result of this is going to be a list of positions. A list of x and y positions. Now we're going to place them we're going to get rid of the legend. So this line right here completely gets rid of the legend that's off to the side. And instead, we're going to use the ggRepel library again to put labels on here. And we're going to give them a few more options than we did before. So we're making the size and the label size. So there's the label is going to be invisible. We're just going to have the words, but the words are going to be quite large. So you see here the result, and this could be improved. You know, we could fix this better. Let's see. Yeah, so we put it on before we put geonPoint on, so it's actually behind the points. So we could put them on top of the points if we wanted to. But anyway, the idea is that we've used the positions in the data to make the positions of the annotations happen. We could also replace the title with a label. So here's a label that looks for a position that's the maximum along the y-axis. So that's the maximum, or no, this is the maximum on the x-axis. This is the maximum on the y-axis. And pastes this label. And I should point out that there's a \n here that's going to break the line of the label after the word is. So now we're going to put the label that we've just created onto a plot that's the same as the plot that we've had before, and we're going to put this in the top right corner. But the precise position, so this is going to generally be in the top right corner, but the precise position of it depends on this value here, the maximum x value, and this value here, the maximum y value. But when I say it's in the top right corner, this v-just and h-just have each 3 positions. V-just can be top, center, and bottom, I guess, and h-just can be left, right, and center. So we can put a general placement of it and then a specific placement of it. Now, here's another approach to doing the same thing. This one ignores the data, so this makes the x-axis infinity and the y-axis infinity, and we paste the same thing here, and we do exactly the same thing. We say that we're going to put this in the top right corner, but instead of the top right corner being the top right corner of the data, it's the top right corner of the plot. So it's exactly as far in the upper right corner as possible. Okay, so the next thing that we can use is scales. So scales have been defined for us. So let's take a look at how they're defined for us. So every time that we have been doing this, these first 2 lines here, ggplot2 has automatically converted it to this. So it's automatically added these for us. And what we can do is adjust them. We can put them in explicitly and adjust them. And we can use breaks in the scale to change the numbers. So what we've had so far has been 20, 30, and 40. And here we're saying we want to go from 15 to 40 by 5. So we're going to have 15, 20, 25, 30. This differs from what we've had in the past, the automatic scale that we've had in the past. And that can be useful, depending on the data, of course. So we can also, instead of putting breaks for the labels, we can put character vectors in, and the character vector can be null. So the null gives us no values. So if we're in a situation where we don't want to share the actual values, we can put null, or we could put a character vector in here, and we could put, high, medium, low, or something like that in here. Okay, and we might have a small number of data points. So this is a situation, okay, so this is the presidential data set. So this is a data set of the presidents since 1953, so the president since Eisenhower. And So it's a small data set, so there are just 11 of them. Trump is not in there, so it's just Eisenhower through Obama. And it has columns including the start date of their presidency and the end date of their presidency. And we're creating an ID from the row number. So Eisenhower was the 34th president. He's in the first row of the data. So we're taking the Eisenhower's row number plus 33 to get the ID of 34 because he's the 34th president, and so on through Obama as the 44th president. Then we're plotting this, and we're plotting those points, and we're also plotting a segment from those points, actually from start to end, because we also have the end date of their presidential term. And we're putting on a scale for the end date. The name of the scale we're leaving as null. This is pretty typical. We're instead manipulating the breaks and the date labels. So the breaks we're taking from the column of the presidential data set, the start column of the presidential data set, and the date labels are those are dates. And so and this is a date scale. So we're using a shorthand here, which is the POSIX formatted shorthand for the 2-digit year, plus we're just putting an apostrophe in front of the year. So %y is kind of a standard notation for 2-digit year. If you have a Linux or Mac machine, you can actually just type in man date. That's not one word, that's 2 words, man, and then date, all lowercase. And among other things, you'll see all the different formattings that you can use for a date. You know, you can have the 4-digit year, the 2-digit year. You could have a string that includes the year and the month and the day, the 3-letter month abbreviation, the full month name. All these are a standard kind of formatting, which is called the POSIX standard, that's published by IEEE, and all operating systems except for Windows obey that standard. And in Windows, you can even get an add-on that will obey that standard. So here's what it looks like. So we have only 11 points, so why not just have an axis label for each one of those points? So these are the start dates for each of these 11 presidents from number 34 through number 44. Now we can also reposition the legend depending on space requirements. So we've been putting the legend when we use it on the right, but we could instead say legend position equals bottom, and we can control the legend guides. So we can say that the legend is of color and that it's one row, and we can override the size of the dots. So this is going to give us if this number is smaller, we have smaller dots. Let me just show you the result. So that number is controlling the size of these dots here in the legend. So this layout might work better if you have a 4:3 aspect ratio than a 16:9 aspect ratio. What you're looking at right now is a 16:9 aspect ratio. And in a 16:9 setting, having something off to the right might be better. But in a 4:3 setting, having something along the bottom might be better because you have narrower sides and taller top and bottom. Another thing that we can do is transform the scales to improve their readability. Now here are 2 different plots. I'm going to show you the 2 plots side by side. They're identical except that this shows the raw numbers, the raw values, and this shows the log to the base 10 of the raw numbers. And what you can see, or what I hope you can see, is that this is much easier to read. The one with the log to the base 10 of the price and caret is easier to read than this one because there's this vast profusion of data down here in the corner, and most of the diamonds are in the vicinity of 1 carat and less than $5,000. That's where most of the data is. We have a few exotic ones that are up here at a higher price and heavier weight. So this is easier to read, but it has one drawback, which is that these scales are kind of meaningless to us. These scales are the logs of the raw values. So they don't really tell us something in terms that we can easily understand. We can easily understand 1 carat, 2 carats. We can easily understand $5,000, $10,000. So what we'd like to do is, in a sense, combine these two, have this kind of scale with this kind of readout. And there is a default way to do that, which is the built-in scales, the built-in log scales. So we've done here the exact same thing. This is exactly the same plot that we saw above, except that we've substituted the log-based scale. And substituting the log-based scale gives us the money along the side and the weight along the bottom. So we can easily place, like 1 carat and this is presumably $5,000 right here. These scales are not even, by the way. So this is probably 500, this is 1,000, 5,000, 10,000. This is going to be greater than 20,000. And this would be a good place to add more detail in the scales to, use the breaks feature of the scales. We can also use color much more effectively than we've been doing. So here we have, and we can use shape, and it's often a good idea to use redundant aesthetics to mark data. So here we're looking at the drive types. So the drive types are 4-wheel drive, rear-wheel drive, and front-wheel drive. And we're using both color and shape to determine them. And then we're using a specific kind of coloring called the color brewer scale to color them. And this gives us this. And the color brewer colors result from extensive user studies. So you can just Google this color brewer, and there's actually an interactive tool on the color brewer website that tells you like which color brewer palettes work better for different data situations. And so you should use, for discrete data, it's often a good idea to use color brewer instead of whatever the default is, because we know how people perceive these colors from these extensive user studies. We might also, though, want to use colors for their traditional meaning. So if we look at the presidential data set again, and we do the exact same thing that we did before, only this time we take the color scale and change it to red for Republican and blue for Democratic, and we see all the president's terms highlighted in the color that's traditionally used to represent their party. Although when I say traditional, that tradition has only been going on, I think, since like the 1980s or something. So it's a fairly new tradition, as traditions go. Now, color brewer deals with discrete scales. There's also something called viridis or viridis. Actually, I have no idea how you pronounce that, for continuous scales. And so we have this normally distributed data set. So this is just a mound. This is a bell-shaped data set. So how would we visualize that? How would we visualize a bell in 3 dimensions? Well, one way that we can do this in 2 dimensions is to look down on it and have the lightest part be the top of the bell, and the darkest part be the bottom of the bell. And that's what we're going to do with the geom hex. So this is going to give us little hexagon-shaped tiles. So here it is without viridis or viridis. And it looks pretty good. You can sort of tell that this is the top, and it goes down, in the normal curve way on all sides. But it might be easier to use a color scheme that maximally lets us tell the difference between the levels. And that's what adding this the viridis color scale does. It makes it easier for us to distinguish the levels, so we can tell what more readily, or at least I can tell more readily, hopefully you can too, what's tall and what's short in this. Okay, the next thing is zooming. So there are a couple of different ways of zooming, and this is the good way, I think. This way here is to take a window on the plot. So we have the same data set we've been looking at, and we're zooming in on the area of engine displacement of 5 liters to 7 liters, and we're zooming in on miles per gallon from 10 to 30 liters. So we're looking at a small window of the plot, and it doesn't lose the surrounding context. So we're getting this smoothing line. So notice the smoothing line, and also notice the error bars around it. We're getting this influenced by all the data points. Now, another thing that we could do instead, which our authors do not recommend, is simply filter out all the other data points. So here we're filtering just the data points in that window, and then we're just plotting those data points. And what happens is the error bars get much wider. Because we have less data to work with, and the smoothing line is much less stable. All right, and then the last thing that we're going to talk about, and this isn't the last thing in the textbook, but the last thing that we're going to talk about in this chapter is themes. So there are built-in themes. We've been using the gray theme, which is the default theme, and there are 7 other themes, including the black and white theme. So here's what the black and white theme looks like. A little bit different from our theme that we've been using, which has a gray background and white lines. You can get a package in addition to so there are 8 built-in themes, including this one and the one that we've been using. You can also get a package of themes that Jeffrey Arnold created that has about 30 themes and a bunch of geoms and some scales in it as well. And many of these themes emulate publications. So this theme emulates the website 538, which you should look at, the website 538. That's a good thing to if you're interested in data visualization, that's a good place to go. Another one is The Economist, and you should also read The Economist. A professor once told me that The Economist is the one publication that most presidents and heads of state throughout the world read. Paul Toll, you can just Google Paul Toll. Paul Toll has a guide for color use that's really good. Solarized is a theme from that programmers use a lot in programmers, text editors, and terminal displays. Solarized is very popular. Stata is another statistics program, kind of like R. And of course, Tufte, we're going to be looking at soon. This is a theme from one of Edward Tufte's books, and we'll be looking at that. Okay, now the default theme is a gray background with a white grid, and it's designed to blend in with the typographic color of the printed page that typically surrounds plots. So plots appear in reports. And the term typographic color here refers to the density of ink on the page. It is a traditional typography term. It doesn't mean colors like red, white, and blue. It means color in the sense of density. So typographic color ranges from dark to light. The idea here is for the plot to blend in rather than to stick out. And I've used this default theme for these slides, even though there's no surrounding print, there's no compelling reason to blend in with anything in particular. So the question arises, do you usually use defaults for design? I often do. I often use defaults in design and leave them unless I have some reason to do things differently. For example, if I were a student and I were in the class of that professor who told me how important The Economist is, I might want to use The Economist theme in that class. And I knew another professor who was nuts about Stata, so I might want to use that theme. So there might be different reasons why you might want to use different themes. I've always just used the default for this, but I know that there are people who don't like the default gray theme and prefer a starker look. Okay, now, as I've said on most of the other slideshows, this slideshow just scratches the surface. You should read the chapters in the Communicate part of the book. That's part 5 of the book for a more complete story, and the ggplot2 book for a deeper look at ggplot2. You can also get some extensions. Let me just show you this. Here's the ggplot2 extensions gallery, and this is ggplot2-exts.org, which may be an unfortunate name because I think ggplot2 is about to change its name to ggviz. So we'll see how that works out. So these are extensions, and we've been using the ggrepel extension in this chapter, and we've used other extensions that are in here in other chapters. And so you can see there are lots of different, we're using the GG themes extension for those. Actually, I took those examples right from this web page. So here are all kinds of extensions to ggplot2 you can get, and there are plenty of websites in addition to the ggplot2 book that are devoted to ggplot2. I think it's the most popular of all R packages, all packages in the R language. So learn to use it. Learn to use it both for exploration, as we did earlier, and as we're talking about today, for communication. And thank you very much for your attention. See you next time.